Next up, we're going to look at factoring polynomials in the form x squared plus bx plus c. And I call this the unfoiling method. This is not an official name, but the other factoring methods have names, and so I wanted to give this one as well. And so our goal is going to be to factor x squared plus 5x plus 6, which is a polynomial in the form x squared plus bx, some number times x, plus a constant term. So this method is going to be useful whenever we have a trinomial that starts off with an x squared and then a term that's some number times x and then a constant term. Now we're going to get to this method in a few minutes, but first I want to look at some multiplications because we're going to see a pattern, and that pattern is going to help inform us of how we can factor these trinomials. So first, let's look at some multiplication problems. We're going to look at x minus 1 times x plus 5. We're going to look at x minus 3 times x minus 3. And we're going to look at x plus 4 times x plus 2. Now, each of these is a binomial times a binomial, and so we can use the foiling method to multiply them out. When we multiply the first terms, x times x gives us x squared. When we multiply the outer terms, x times 5 gives us a positive 5x. When we multiply the inner terms, negative 1 times x is negative 1x. And when we multiply the last terms, negative 1 times 5 is negative 5. Now we recognize that there's like terms here that can be combined. So when we combine them, we end up with x squared plus 4x minus 5. And we can do the same procedure for the other two examples here. Let's look at x minus 3 times x minus 3. When we multiply the first terms, we get x squared. The outer terms give us minus 3x. The inner terms also give us minus 3x. And the last terms, negative 3 times negative 3, give us positive 9. Again, we can combine like terms, and when we do that, we get x squared minus 6x plus 9. In our third example, we can also multiply by foiling. When we multiply the first terms, we get x squared. The outer terms, we get 2x. The inner terms, we get 4x. And the last terms, we get 8. And when we combine the like terms, we end up with x squared plus 6x plus 8. Now, we're multiplying here, but the end goal is factoring. And so what I want to do is I want to notice that whenever we have a product of two binomials where they're all in the form x plus or minus a number, whenever we multiply a pair of binomials like this, we end up with a trinomial that always starts off with x squared, just like our example, and then we've got a term that's plus or minus some number times x, and then we've got a constant term at the end. So we end up with something in the form x squared plus bx plus c. So because we end up with something in this form when we're multiplying binomials that look like these, if we go in the opposite direction, if we try and factor something in the form x squared plus bx plus c, the result is going to be a product of two binomials, x plus one number times x plus another number. And I'm going to use m and n to represent those. So in these problems, we're going to be given a trinomial in this form, and when we factor it, we know we're going to end up with a product of two binomials. And so we're going to play detective here because we're going to be given certain information and we need to use that to figure out what the result is going to be. So the information that we're given is actually B and C. We're given these two numbers. In this case, B is 5 and C is 6. And we need to somehow use those to figure out the values of M and N. So given these two numbers, B and C, what we need to do is we need to find M and N. But there's two things that we know here that are going to help. If you look at the value of B in all of these problems, we've got 4, -6, and 6. This coefficient on the x, this number, comes from the sum of the two constant terms, m and n. -1 plus 5 gives us 4, -3 plus -3 gives us -6, and 4 plus 2 gives us +6. So we know that this number B is the sum of M and N. Similarly, we can make an observation about the constant term C. How can we take -1 and 5 and end up with -5, and also take -3 and -3 and get 9, and take 4 and 2 and get 8? Well, the answer is multiplication. -1 times 5 is -5, -3 times -3 is +9, and 4 times 2 is 8. So in this case, that constant term C actually ends up being the product of M and N. And these two facts here are going to be enough for us to work our way backwards, starting with a trinomial and figuring out what these two numbers are so we can get our factorization. Let me show you how this works. Let's factor x squared plus 5x plus 6. Now this is in the form x squared plus bx plus c. So from our observations, we know that the factorization is going to be a product of two binomials that start with x. But what we need to do is we need to find the constant terms that go in here, the m and the n. But we are detectives and we have two clues to help us figure this out. We know that B is the sum of M and N. In this case, B is 5, so we're looking for two numbers that have a sum equal to 5. And C, the constant term, is the product of M and N. In this case, C is 6, so these numbers that we're looking for, they have to have a product of 6. I usually write the product on top and the sum on bottom. It's just a habit I get into, so I'm always doing things consistently. Anyways, we're looking for two numbers, and we know they have a product of 6 and a sum of 5. You might be able to figure out those numbers in your head just by looking at that in 2 seconds. You might already know the answer. But if you don't, there's only so many possibilities we have to consider. We're looking for numbers that have a product of 6. Well, we know 1 times 6 is 6. We know 2 times 3 is 6. We know -1 times -6 is 6. And we know -2 times -3 is also 6. These are the only ways that we can end up multiplying two integers and get a product of 6. We just need to see if any of these pairs have a sum of 5. And we notice that 2 plus 3 does equal 5. So that means the other ones are not correct. And in fact, the numbers we're looking for are +2 and +3. And that tells us that our factorization will be x plus 2 times x plus 3. It might seem a little bit weird the first time you do it, but when you get practice with this, it ends up being a lot easier. Let's do one more. Let's factor y squared minus 5y minus 24. Now, it's not a problem that our variable's y instead of x. That's fine. We still have a trinomial that starts off with y squared instead of x squared, and then a constant times y, and then a constant term. Because we've got a trinomial that's in this form, we know that the factorization should be a product of two binomials that both start with y, and we need to figure out what the numbers are that go in these binomials for the constant term. But we have two clues. We know the product is going to be the constant term, which in this case is negative 24. So we're looking for two numbers that have a product of negative 24. And the sum is always the value of b. In this case, that's negative 5. That's always the coefficient on the x term, or in this case, the y term. So we need two numbers that have a product of negative 24 and a sum of negative 5. Now, there's a lot of different possibilities to give us a product of negative 24. We could have negative 1 times 24, or negative 24 times 1. We could have negative 2 times 12, or negative 12 times 2. We could have negative 3 times 8, or negative 8 times 3. Or we could have negative 4 times 6, or negative 6 times 4. There's more possibilities here, but there's always a finite number of possibilities. And now we need to go through and see which of these give us a sum of negative 5. And if we go through them one at a time, we can get rid of the ones that don't work. And then we do, in fact, see that negative 8 plus 3 does give us negative 5. So the two numbers we're looking for are negative 8 and positive 3. So our factorization is going to end up being y minus 8 times y plus 3. Now, two very quick notes here. The order of the two factors does not matter. So we could have also put y plus 3 times y minus 8. It's the same answer, no problems. And then the other thing is that if we cannot find two numbers that have the given product and the given sum, if there don't exist two numbers that have a product of something and a sum of something, what that means is that it cannot be factored, and in that case we say the polynomial is prime.